Hey everybody! So this video is about direct current and alternating current. So there's actually two different types of current in terms of the way it can flow around a circuit. Direct current is the first one, and it's the current you know about already. So every circuit we've learnt about so far uses direct current. So in direct current, the electrons move in one direction and they continually move around the circuit in just one direction only. So electrons move in one direction. So we've looked at these kind of circuits before. You've made them in the circuit builder. So when we connected batteries in a circuit, we knew that the electrons started at the negative terminal and they flowed around the circuit in one way and they ended up at the positive terminal. So they moved from negative to positive. So the key here is that circuits that use batteries, these are the ones that use direct current or DC. So you can see these devices here, things like your remote control for the TV or your mobile phones, anything else that uses batteries, these use direct current. And that's because batteries only produce a direct current. So anything that's run off batteries is going to be using DC. But the other type of power is called alternating current. And we're going to look at a simulation first to picture what alternating current looks like. So here we've got a light switch going up to a globe. And let's look at the electrons in direct current first. So this is what we expect for electricity. The electrons, the little white dots, are moving around, the little red dots, they're moving around the circuit in one way only, through the switch, through the light, which is a resistor, and that's causing the light to light up. So there's nothing new there. But in alternating current, the current moves a bit differently. So here's alternating. So straight away you can see in alternating current, the electrons move back and forth. They don't flow around the circuit in a loop. They just oscillate, or they go one way and then they go the other way. But there's still electric current being transferred. There's still electrical energy being transferred because there's, and we'll reset it, because as the source of the power, and that's off the screen to the left here, it's producing electrical energy, and that's pushing the electrons through the light, and then it's pulling them again. So pushing and pulling the electrons. So electrical energy is still being transferred, but the electrons don't flow all the way around. Here's another analogy, which is using the water pipes analogy. So if these water pipes were an alternating current, you can see that the energy source is pushing the water one way and then it's pulling it back the other way. So the water is flowing back and forth. So really, one individual water molecule, it's not traveling around the whole circuit like direct current. It's just going back and forth, but the energy is still being transferred from the power source to the resistor. So AC current still transfers energy. So that is our summary. AC current Electrons move quickly back and forth. In other words, they oscillate. So here's an example of two circuits. So we're used to seeing DC circuits where you have your battery, which is the power source, and we know that the current only flows from the negative terminal to the positive through the load on its way past. But in AC current, we draw the AC power source with this symbol, and you can see here that the current goes one way and then it goes back the other way. So, the place you've seen AC current before is coming out of your power points at home or in any building. So alternating current, that's the type of electricity we use that along power lines that come into every building around the world. So alternating current comes out of the wall. So that means any device that you plug into a power point, or most devices, they are going to use AC power. So think about all those appliances in the kitchen, the fridge, the dishwasher, the toaster, whatever you use, plus all the lights that are connected to your house's circuit as well, and any lamps that you plug into the power point to. So there's two kinds of power, great, but why do we actually use AC power? Why don't we just use DC throughout buildings as well? Well, the main reason is that DC power loses a lot of energy as heat energy, so it's not very efficient. Whereas AC, or alternating power, you can transfer that along power lines for kilometers and it doesn't lose as much power. So it loses less heat. So it's more efficient and there's less waste. So let's look at how electricity actually gets to our homes now. I talked about high voltage power lines before. So there's four main stages from how electricity gets to make it into your house to actually use it. The first one is that the electricity is made at the power plant, whichever power plant it's being made at. In Victoria, we have mostly coal plants. Hopefully that will be changing really quickly in the next few years so that we're not producing so much carbon emissions. So the power plant generates the electricity, and at the power plant it's a low voltage. But to transport power over long distances, it's better to have that power at really high voltage because that's also more efficient. So the next step is that the power is converted to high voltage at the power plant, and it travels along these high voltage power lines that you've probably seen out in the country. So now that it's high voltage, and remember it's also AC, because that's more efficient too, the high voltage power travels along the power lines until it arrives at a city or a town that needs some power. So then engineers have designed these places called substations. And you've probably driven past some, they're all around the suburbs. And these are places where the high voltage power from the power lines is converted back to low voltage, because high voltage that's used in these power lines is way too dangerous to use in your home. It would blow up all of your appliances, whatever you plugged into the power point. So the next stage is that the power substations, they convert the electricity back to lower voltage again. And then from there, the power can travel along the smaller power lines that you see along the street. And then from there, it goes into each house, ready to be used when you plug something into the power point. So low voltage AC power flows into your house. So they're the main stages of how you get power. And this is the basis of how every modern country generates its electricity. One amazing thing to think about is that the whole of Australia is really one giant circuit, because every state has its own area where they have their power stations. In Victoria, it's in Gippsland here, where we have lots of coal, so that's where we decided to build all our power stations. But you can see on the map here, all these blue lines, these are the high voltage power lines that take power from Gippsland to Melbourne, but also out into the country to all the regional areas. And in particular to the aluminium smelter, where we make aluminium, and to the desal plant. These places need lots of electricity for what they do. But also you can see high voltage power lines go off into South Australia, New South Wales as well, and every state in Australia is actually all connected into one giant circuit. The last thing to look at is some devices actually convert power between the two. So any device that you see where you plug it into the AC power point, but it has this little black box, these devices are transforming the AC power into DC, so that device can use it. So these devices convert AC power to DC using a transformer, and we often call them adapters. So that little black box there, when you're charging your laptop, it's taking the AC power and using different components, it's converting it to DC for the laptop to use. And actually modern TVs do the same, because they use LED lights, and LEDs can only run on a DC circuit. So TVs have an adapter built into them, you can't see it. Other things that convert AC to DC are electric cars. So when you plug in a Tesla into the AC charging station, it converts its power to DC, so its batteries can be charged. Because remember, batteries only ever use DC. So any device that uses batteries, or rechargeable batteries, you will usually convert AC to DC.